Okay, Year 12. Someone's asked about this question here with applications of calculus to curve sketching. It's an exponential. Would I worry a lot about this one? No. It's quite difficult, but I have done it. So I'm going to put up my method for solving this straight away. You'll see here that the first thing is it's just asking for the stationary points and determining their nature. But down here, the person who asked said that they want to show points of inflection, and I think it said graph. Is there answer also draw it? Yeah, so we've got to graph it. So this gets pretty nasty with the algebra. Don't, if you're watching this video and you're thinking, oh, I have to understand that, don't. The ones I will give you will not be as difficult with the algebra as this. So here we go. So I'm going to start with the equation, which is f of x equals e to the 2x plus 1 times x to the 4. So this seems like a really easy product rule, and the first differentiation is pretty easy. But before I go into the first differentiation, you should realise that when x equals 0, f of x is going to equal 0. So we know this thing is going to go through 0, 0. So we've actually got 1 point already. And remember, plotting points is your best friend. So let's differentiate it. So the first thing is f dash x, and remember it's the first, e to the 2x plus 1, times the derivative of the second, which is 4x cubed, plus the second, x to the 4, times the derivative of the first, which is e, the same thing, e to the 2x plus 1, times 2. Now, I'm going to factorise it, and I'm going to take a e to the 2x plus 1 out. I'm going to take a 2x cubed out, and let's see what I'm left with. Now, if I do that in here, I take that out, a 2 and an x cubed, I'm only left with a 2 plus. And if I do the same thing here, what have I taken out? I've taken an x cubed, a 2 and an e to the 2. So I've only left with an x. So the first differentiation isn't that hard. All right, we'll just tidy it up. 2x cubed e to the 2x plus 1, 2 plus x. And I've got it fully in factorised form. Now what I would do here, I don't want to differentiate that again, so I'd use the first derivative test to determine the nature of the stationary points, which I'm going to do. So, but I am going to have to differentiate it again to find the points of inflection, and that's a whole nother, it's pretty hard that, so I'm going to leave that to do over here later. So let's just find stationary points when f dash x equals 0. Well, that's 2x cubed e to the 2x plus 1, 2 plus x equals 0. Well, we know that that can't equal 0. This is going to give me x equals negative 2, and this is going to give me x equals 0. And remember, we like to write, well, the solutions are we write them left to right, x equals negative 2, x equals 0. So now I'm going to find f of negative 2 and f of 0. We already know f of 0 is 0, so I've got this stationary point at 0, 0. And I've got another stationary point at this negative 2, so I just get my calculator out. Unfortunately, I don't have the calculator emulator on this device for... well, yes, I should. Yes, I should. So I'm going to actually go to here and... oh no, I've got to go to... no, I'm just going to use this calculator. I'm going to go old school. And you can see I've already been doing it. So I'm just going to go back here and change that 1 to a negative 2. Actually, I'll delete that and write it properly. 2 times... oops, negative 2 plus 1. And I've got a negative 2 in here. And I get 0.797. 0.797. So now I've got this other point. I've got these two stationary points, negative 2 and 0.797. Righto. Now to determine their nature. Well, I haven't done the second derivatives, and it's going to be pretty hard. So I'm just going to use the first derivative. So I'm going to go a little bit to the left, negative f dash of negative 3. I'm going to find out what that is. I'll go a little bit to the right. I'm going to go f dash of negative 1 equals. Now, remember, f dash is here. This is f dash. Well, you can look up here. Here it is. Same thing. And I'm going to put that in my calculator as well. And the first number I'm putting in is negative 3. So it's, first of all, come on. Right, so 2 times bracket negative 3 squared cube, sorry, e to the 2 times negative 3 plus 1. And then I've got 2 plus negative 3. I need to get rid of that power 4. Righto. Holy dooly, that's not right. I've done something wrong there. 2 times negative 3 cubed. Oh, I haven't got a negative with the 3 and the e. Oh, that should have a negative in there. Okay. That sounds a little better. 0.36. Where's my pen? I have that right on. 0.36. And now all I have to do is go back to my calculator and change that to negative 1 all the way through. Remember, you would have done this on your table. Negative 1. So you would have done it a whole lot quicker. Negative 1. And negative 1. Oh, I lost the negative. Righto. We're at negative 0. What was it? 7 something? That'll do. So what's happened? It's gone from positive to negative. And remember, you should know that negative, 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 positive, 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 negative, negative, negative. So this one, it's gone from positive to negative, so it's a max turning point at negative 2, 0.79. Now I have to go a little bit to the left of 0, and again, I've already done that. I've just done f of negative 1, so all I have to do is go a little bit to the right of 0, so I'm going to f dash of 1. I'm going to find out what that equals, go back to your calculator, get rid of all those negatives. It's so much easier if you're using your table. I hope you're doing that with your new calculator. And 120. 120, which is greater than 0, which means it's now gone from negative to positive, which is this one. So it's a min TP. So I've found the stationary points and I've determined their nature. Now, to find, this is going to be hard now, to find the second derivative. Oh my goodness. I have to have 2 goes at this. It really, if I leave it, so I've got my f dash and it's e to the 2x plus 1 times 2x cubed times 2 plus x. Now you can see I've just swapped the order of the front two, but it doesn't matter because we're just multiplying. I don't know about you, but I don't know about a triple product rule because I've got 3 products here. So I'm going to put this back into there so I can use the product rule. So watch what I do now. And I get e to the 2x plus 1. And I'm putting that 2x cubed back in there. So I get 4x cubed plus 2x to the 4. So I've just put it back in there. Now I can do my product rule and I can find f double dash of x equals the first e to the 2x plus 1 times the derivative of the second, so 12x squared plus 8x cubed plus the second. I'll go over here, I'll do it properly. I'll keep it all on one line. The second, so plus the second 4x cubed plus 2x to the 4 times the derivative of the first, which is 2 e to the 2x plus 1. Right, again, I'm going to factorize because what am I doing this for? I'm trying to find when the second derivative is equal to 0 to find points of inflection. So I'm going to take a e to the 2x plus 1 out of both of those. So I'm taking it out of there and I'm taking it out of there. And what am I left with? Well, I'm left with a 12x squared plus an 8x cubed plus, remember I've got to put the 2 into these two, another 8x cubed, because 2 times 4 is 8, plus a 4x to the 4. Right, you can see how this is crazy. E to the 2x. I'm not worried about that because that can never equal 0. I tidy up what's inside the parentheses. So I'm going to put the 4x to the 4 first, my leading term. I've got 2 8x cubed, so I've got 16x cubed. And I've got a 12x squared. Right, let's get that factorising. I'm going to take 4x out of that. So I'm going to take 4x squared out of that. I'm going to take 4x squared out of all these, which means I'm going to get a x squared there. I'm going to get a 4x cubed there, and I'm going to get a 3 there. Right. So when, hold on, possible PI when f double dash of x equals 0. Righto. Well, we get x equals 0 for this one here. But we've already dealt with that. We know that that's a min TP. So we disregard that one. So now we're just going to see when this equals 0. Because remember, this can't equal 0. So, a lovely quadratic. X squared plus 4x cubed plus 3 equals 0. Righto, what multiplies out to 3 and adds up to 4? 1 and 3. X plus 3, x plus 1 equals 0. So we've got when x equals negative 3 or when x equals negative 1. So now I have to check that concavity changes. Well, f double dash a little bit to the left, negative 4, and f double dash negative 2. Now to save time, right, we can go and do that on our calculators, but I went to Desmos and I put these in. So have a look because that's going to help us with the curve sketching anyway. So it's coming. I hope it's coming. Righto. So where's my values gone? Oh, come on. Where are you? Go. Right, so there's my function, and you can see what it looks like now, which is going to make it nice and easy. There's me putting points in to find the function. So I'll put -3, -1, 0, and -2 because they're my critical points, aren't they? The first two are going to give me, so we'll do them first. So -3, if we find the x, it's 0.5, and -1 is 0.36. So let's go back and go, well, yeah, we should have found the y value. So f of -3, what we say, equals 0.5. So there's our point. And f of -1, what was it again? Double check. 0.36. 0.36 equals 0.36. Now, we're checking to see if concavity changes either side of -3. So you do that on your calculator and you make a table. I went down here and found f double dash of -3. Sorry, what I need, check f double dash. So I better do that again now. So there's me showing that f of -3 and f double dash -1 is 0. And I have to now go, why doesn't it let me type in a new one? No, let's get in here. And this is, oh, come on, stop stalling me. Righto. So I want f double dash of, oh, get out of there. Get out. I'm just going to put in there, what did we want? -4. Come on, just do as you, no, hold on, yeah, do it. Let's get rid of you. And it's 0.17. So I go back, 0.17, 0.17, which is greater than 0. And now I want f double dash of -2, so I go back there and do it again. Come here. And I change that to a 2. And I get -0.7. -0.7, which is less than 0. Concavity changes. Therefore, pi at -3 and 0.5, or thereabouts. Well, I've already gone to the left of -1 and shown that it's negative, so let's just go f double dash of 0. Oh no, we can't do that. If we do f double dash of 0, we'll get 0. So I have to go a little bit closer. So I'm going to go f double dash of -0.5. All right. So go back here. F double dash, get in there, delete it, and put 0.5. And it's 1.25 equals 1.25. Oh, did I put -0.5? I better double check. Yeah, I did. What did we say it was? 1.25, didn't we? 1.25, which is greater than 0. Therefore, concavity changes from negative, look, you can see here, from negative to positive. So concavity changes Therefore, pi at -1 and 0.36. Right, so we've done all that. That's second derivative. Very hard. So let's sketch it now. Get myself a number plane. And what are our points? Well, we've got 0, 0, haven't we? And we've got negative, what are my other points? -2 and 0.79. So let's just go along here. -1, -2, -3. And at 0, 0, we know we've got a minimum TP, and at -2 and 0.71, let's do a really big scale here. Let's make that 1. So it's -1, -2, -3. By the way, it's really hard to draw on a tablet, so you're going to have to excuse this. So -2 and 0.79, so I've got this point here. -1, over here, our -1 and 0.36, so -1 and 0.36, and our -3 and 0.5. So it changes concavity, and we'll go like that. Actually, I'll get rid of that because it actually goes, I'm not sure, but I think there might be an asymptote there. Let's have a look at what it looks like on Desmos, and you can see those critical points that I indicated. It's going to be clear, that one, that one, that one, and that one. And that's your turning points and your points of inflection. There's an asymptote as it approaches 0, because you know that it's never going to go near 0, because that e to the 2x plus 1 will never be negative, and neither will that x to the 4. It doesn't matter what number you put in for x to the 4, it's always going to be positive because you're squaring it and squaring it again. And your e to the 2x plus 1, well, that's always positive. All right? So it's never going to go past 0. My only question is, where does that go? Does it have another asymptote at x equals 1? I don't know. It certainly looks that way, but it goes up. But I don't know if that was part of it. I would imagine that all you would have had to have done is sketch it like that. That was really hard. That was quite difficult. I probably won't give you one as hard, but look, what did we do? Let's go over it again. You differentiate it. You factorize it. You go, I'm not going to differentiate it again. That's too hard. You find the stationary points and you use the first derivative test either side to determine the nature of those two stationary points. But you have to do the second derivative anyway. I had 3 products, so I put that 2x cubed back into that 2 plus x, used the product rule again, factorized again, got an x equals 0, which we already knew about, and got a quadratic, which was pretty easy to factorize and solve. And we got our other 2 turning points, and points of inflection, and we showed that concavity changes so that they were points of inflection. All right, hopefully you've got that, and it's all good. Good luck.